So, without further ado, I want to welcome everyone to today's webinar. And basically, before I give floor to our speaker today, just want you to thank you for being here and just try to say a few words about João Barbosa, which is our speaker today. So today's webinar is From Code to Scale, EPICURE Services, Stories, and Training for EuroHPC users. And basically, we are delighted to welcome you and to present an overview of EPICURE's Level 2 and 3 support services, which include code enablement, scalability, performance profiling, optimization, all provided free of charge to EuroHPC allocation holders. And our today's speaker is João Barbosa, which is the technical lead for EPICURE and heads the high-level support team at IT4I Innovations. And it supports researchers in code optimization, parallel computing, and application scaling in Europe's leading supercomputers. If you want to interact with us, and after the webinar and the speaker ends its presentation, we'll be able to have some questions, some Q&A parts. So feel free to ask several questions on the chat here. And so let's enjoy. If you want more information, we can even talk a bit more later on, and we can actually reach out via email. So feel free to reach out to us and talk with us. Okay, so the floor is yours, Ron. Go ahead. João, you are currently muted.
How about now?
Go ahead.
Okay. Good morning, everyone. Welcome to this webinar. We are going to talk a little bit about the story of EPICURE and what it does and what it does not do, and some examples, user stories and cases that have happened in the past, and that can give us a light, at least for you, what we are able to do for you. Okay. So this is our agenda for the webinar. What is EPICURE? What are the support services? How can you apply for them? Some of the success stories, our knowledge base and training portal, and then a little bit of Q&A. So we'll have time to discuss a little bit yourselves and your projects and see if we can help you or not. Okay. So EPICURE is a 4-year project. It covers all EuroHPC sites. So 17 partners in total. There's not 17 supercomputers, but there's some supercomputers that have more partners involved, so even them are part of it. An example of that is Lumi. There's about 8 countries involved. So all of the countries that are involved with Lumi are in the project itself. This is so that we can bring the user support closer to the community instead of talking to someone remotely in Finland. Okay. So far, we have supported more than 80 projects in the last couple of months, or in the first 2 years. To be accurate, we are now around 209 projects in total. Some of them are in progress, most of them are in progress. The most important thing is that these projects are attached to a high-level support team that will perform level 2 and level 3 support, meaning that will help you run your code and optimize your code for all the platforms, either porting, optimizing, doing advanced training, whatever needs to be done. And This is also true for centers of excellence and national competence centers, so EuroHPCs and so forth. Okay. So which type of projects that we support? Extreme scale access, regular access, development, and benchmark these days. As you can see, this is the same naming convention as the calls from EuroHPC JU. So you can apply, and you'll see later, we'll discuss it a little bit later. You can apply for resources with the EuroHPC JU to one of these types of projects. And once you do that, you can actually come to us and we'll help you through your entire allocation. So it's not a ticket system; it's a continuous support through the entire allocation. Okay. Unfortunately, we do not support national projects. Um, so if you need our support, you need to apply for your HPC resource allocation to one of these projects. Okay. So exactly what we do: code enablement, performance analysis, benchmarking, code refactoring, and code optimizations. These are all ugly words and ugly terms, but the fact is, code enablement is no more than making sure that you can run the code that you have and the problem that you have on the machine in the most efficient way. And if it's your code, we'll do performance analysis and find a way of making it run faster and using the right resources within any of your HPC machines. If you are applying for something like an extreme call or a regular call, you can apply for a benchmark and we can help you benchmark your application so that later your calls, extreme and regular, will have a success. And then, of course, if the code is yours and you actually need support in optimizing in scale, meaning getting out of your local machine or a single set of nodes and coming up to the scale of a Lumi, a Mare Nostrum, a Deucalion, Jupyter system, will help you improve your code, so refactor it, or even optimize it through the performance analysis that we have, where we can see what the bottlenecks are and then help you with tackling the machine efficiently and optimizing the code as efficiently as possible. The goal is so that you can use your resources as efficiently as you can. That's the goal. And to remove from you the headache of trying to figure out exactly what is the best way of running your code on these machines. You should, for those that do research, you should focus on your research, not specifically on the code and code optimizations that belong to the computer science field, computer engineering field. Okay. So we have this divided into levels, level 2 and level 3. This is because typically we refer to support levels as 1, 2, 3. Level 1 is something that we do not support, which is getting your passwords, getting access to the machine, have a particular software package installed, um, basic things with the system. So we don't do that. We end up on the other end, which is do some small code porting, making sure that your code actually scales to more than a couple of nodes, and you can use hundreds of nodes to do that efficiently based on your problem that you have, and so forth. If there's problems with compilation, making sure that it vectorizes correctly for for the machine that you're targeting. So all of that is covered by level 2. And then level 3 is the highest level that we offer, which is actually code optimization. Meaning, if you own the code and if the code is yours, then we can join with you and partnership with you so that we can improve your code performance in terms of parallelism, in terms of communication, in terms of performance in targeting accelerators, GPUs, and other things, so that it can take out the most of the machine from your own code. So that's code optimization. Okay. So things that we don't do, general information, the things I was talking, level 1 stuff, basically general information about the machine, login access to the systems, setting up your environment, preparing workflows and some work, job scripts. If you are dealing with that, that's all dealt by level 1. Building containers if you need to build them, although we can help you improve your containers. So that's the difference between those two things, right? And then standard software that it's not related to your project at all. So those are all level 1 support things, and they should be dealt with level 1 directly with the machine that you are targeting. Okay. So how does this work? Well, the first thing is you will need to submit an EuroHPC access proposal. They are extremely easy to submit, especially the development and the benchmark. They are extremely fast turnover. You get your answer in a week to 3 weeks. You'll get an answer which usually is positive, uh, but you need that allocation and you need that communication from the GU, right? In the form that you support, there is a checkbox there that says that asks you if you need AST support, which is EPICURE support. In that case, just say yes, and the request will also come to us. Okay. Once that proposal has been approved, you will receive an email from the EuroHPC GU with a link to come to us. You will fill slide form, very small thing. We'll approve it and assign you to a specific team. The goal of that form is for us to know exactly what you need, so that we can change. We can get the best elements to support you instead of assigning a random team to you. Okay, and then it's just collaborate until your application ends. It doesn't mean that the collaboration immediately ends there. There might be a little bit of a gap so that you can get your results and get your things. But usually it ends there. It's not unusual for people to do continuation projects, meaning I start with a development project, we don't finish, and you apply for a second development project, so that we can finish the work that was not done. So the process itself, it's extremely easy, and I really do advise you to apply to the EuroHPC access proposal. Sometimes it's a lot easier than applying to the national grants and to the national calls, and then they are always open. At least the development and the benchmark, they are always open, and it gives you enough resources to start. And once you get familiar with it and you need more resources, you can try the extreme and the regular call. Okay. This is just a summary of what we said before. So things that we've finished already, uh, projects there have been completed, more than 80 projects. Most of them were code optimization. Some of them were AI and LLM projects. Uh, and others came in for benchmarking, profiling, or enabling for um, porting projects. And this part of the porting is more related to level 3, meaning optimizing the code, porting to the GPU, or porting to a specific architecture, something needed, right? For instance, Jupyter is coming in. It has the ARM process, the Grace processor from NVIDIA, plus the NVIDIA cards. So if you find problems there, we can help you. Lumi is a very tough machine to work on sometimes due to the complexity of its architecture, and especially because it's using AMD GPUs. And sometimes we need to adapt. We have the code in CUDA from NVIDIA, which will not run on AMD hardware. So we'll help you do the porting between the two systems so that you can run independently in one or the other. Okay. Some projects that have been successful. I just chose 3 of them from energy, environment, and climate change. One was simulating a catalyst reactor. The code itself was from the person itself. It was a code written in Python. When he tried to run the code, it was extremely slow for a lot of reasons. One of them is because he was using a standard Python library by using either Conda or the pip environments, which are not optimized for the machine itself. Those packages are optimized for generic machines, so they should run everywhere. Um, and what we did was to replace them with efficient implementations of those libraries, and the performance improvement was almost 20x. Right. The same thing for the environment, although it's not seems like not a significant result. 7% speed up in real work life means a lot of resources, right? If you're thinking about 7% in an hour, it's not much, but 7% in 48 hours with lots of machines, it's a lot of resources and a lot of time gained back. Okay. And I also chose the heart language model function from Meluxina, where the goal was to train a model in multiple nodes and multiple GPUs environments. And we were able to improve the communication and usage and the throughput. TensorFlow does a really nice job, but sometimes some additional tuning is needed for the machine itself to take into account the architecture of the machine. And we were able to get some reduced time in training, some significantly reduced time in training. We cannot say exactly how much, but it was substantial. Okay. So other projects, this is one that was in Lumi was very complex, large scale simulation for physics. They needed a lot of help. One, benchmarking the scale-pack library that they were using that was not being performance enough. Investigating a package that they have, which was ALPA, and they had a really old Fortran code that we needed to refactor and improve so in order to maintain maintainability. So getting to a more recent version of Python to do that, and they also wanted to expose portions of it to Python so that they could use um, machine learning integration into it. So the end result is that we were able to speed it up a lot, especially the ALPA package, where on average we were able to get somewhere between 2 to 5% faster than what we were using, what they were using with Scala pack. And even for really large systems that they were not being able to target, we even got speed ups that were extremely higher than that. And we developed a Python wrapper for integration with machine learning to their team. Okay. Uh, and this is the case where sometimes machines need to be carefully studied, and the assumptions that we have sometimes are not correct, right? Um, so when we look, for instance, to an NVIDIA machine and we try to compare the two of them, the way that they connect to the CPUs and the way that they share memory, it's not exactly the same, which sometimes introduces slowdowns if you want to communicate between GPUs. This is particularly sensitive on Lumi. Um, on Lumi, due to the architecture that Lumi has, each compute node has um, the way that we communicate between the CPU and the GPU. Sometimes will introduce delays, and being able to place correctly your application on the GPUs is critical in order to get performance. This work was actually done with someone that it's online. I think Bert is online, so if he wants to add something, please stop me. Um, but one of the things that we were able to do for them is to get them to run successfully and efficiently the software that they wanted on Lumi without losing too much performance and so forth, and to deal with the complexity of uh, the Lumi system, which is a gray. Sometimes it's difficult to work with if you don't know exactly what you're doing. Okay. And finally, a work with microHH. It's from Hidalgo 2. Their objectives were to make sure that their application WR S-Fire was running in all the systems, that it was transversal, um, and that you could calculate in real time wildfire spread simulation works. So what we did was to support them in different ways. One, making sure that the library is optimized for each one of the machines, particularly the microHH, make sure that it was done correctly. And we also developed recipes, not only here it says for Lumi, but it was not only for Lumi, it was for all the machines. So Easy Build is a way of installing software and dependencies, and you can actually do it for in any machine for your own home and have this package that deploys everything correctly. And we help them get those recipes working um, and get them to quickly deploy to all the systems within the EuroHPC ecosystem. And if they make changes, they can redeploy them again easily through the Easy Build platform. Okay. And just another example. One of the things that sometimes we have trouble dealing with is making sure that we can use efficiently all the resources and that we can efficiently target the machine and fill it up. Sometimes we do a software and we only use portion of the system. This was an example of it. Um, Distributed FTD is known, but it's somehow really hard to coordinate, and it depends a lot on the machine that they're using. So we help these users, one, to get the code running efficiently, in this case on Leonardo, making sure that he was able to use all the GPUs that were available in multiple nodes sequentially, and above all, get to the as close as possible to the theoretical threshold so that they could do more work um, simultaneously than they were doing before. Okay. And all of this knowledge is now being collected on our application support portal. So if you look on the web, I should have put here the URL. Sorry for not doing that, but I'll send it, or I'll ask someone to send it to you, um, where we are putting in all the knowledge that we have, experiences that we had, things that work and things that don't work, assumptions that some people have that are wrong, and or problems that they think that are not solvable. What is the solution? So we're putting there how-to guides, best practices, some on-demand training with recorded sessions, lectures, and other content, and some code snippets to help out and start doing some jobs. Okay. So Epicure is basically here to help you as much as we can. We we have worked in the past, and we hope to work with you guys in the future to get your codes to run efficiently on EuroHPC machines. We are not competing with you. We are just another team to help you get your objectives. And your objectives is not running code. Your objectives is getting your research done. And that's why we are here for. Okay. Having said that, thank you so much. And questions?
Okay. Everyone can ask questions in the chat, and we'll try to be as fast as we can. But I actually have a couple of questions. You presented
Sure.
three use cases, three success stories. But since we are here in the middle of a lot of success stories, what about the ones that are not so successful? Are we able to actually see those ones and like try to say to the users, okay, it was not feasible to do what you wanted, and we're not able to actually do anything with your code?
There are situations where that happens, right? But it's unusual that it happens, right? There's always something that will help the user improve the way that they are doing their code. Um, there's always something, because each one of the machines has its own particular architecture and way of connecting, and just simply, for instance, changing the binding that we do to the cores or the GPUs helps substantially. There are those where we cannot help because we cannot even have access to the code, right? It's proprietary code, and we are not allowed to touch that. Uh, I'm remembering things like fluid dynamics. ANSYS is one of the common ones. Molecular dynamics. There's a couple. Amber, which the code is closed code. You actually need a license to run it. And in those cases, there isn't much that we can do. But there's always some kind of lesson that we take out of it, or at the very best, at the very least, um, either the user learns something new, if it's a new or mid-level user, or we learn something with a really high-skilled user. So and the learning goes both ways.
Yeah, makes sense. But you said sometimes we don't have access to the code, and that is correct, unfortunately. I was just thinking, like, what if we actually add a way to use NDAs or a way to keep the code private, but the users trust us as a support team. Are you thinking in a way how actually these projects could help in improving that support, that private support?
We can do NDAs, and the NDAs will be always be between the project and the support institution, or the support team that is involved. Or um, we haven't had the case where an NDA is needed, uh, because we most of the time we're able to substitute it by surrogates, similar codes that do exactly the same thing, and that they can take out experience enough to improve their code on their own, right? Um, but in any case, I'm thinking about a couple of codes that are not open source and they are closed source, uh, and there are thousands and thousands of lines that they could help. It could be beneficial for them to use us, but because they are commercial, they are not very keen on doing that. So there's a barrier there. The only codes that I know of, um, and we did that with an AI company, was to create a surrogate um, that is close to what they were doing, close enough so that they could get an experience out of it, and they did. They actually improved a lot their own system from the experience from the surrogate, and they improved a lot. They learned a lot from that experience to the point that they got funded again, and they are evolving. Um, but there are cases where we cannot do anything, right? Um, one of the things that these types of systems depend on is the fact that we can make the code and the algorithm parallel. And if the user persists on having a very sequential code for one reason or another, I'm remembering a specific case where the user simply doesn't, when it goes parallel, a couple of decimal points changes, which is natural on parallel architectures due to the way that they compute. And because of that, he basically panicked and said, no, we cannot do that. And in that case, what we did was set up for him a batch pipeline in Slurm so that he could at least do more experiments simultaneously.
Yeah, it's a bit difficult. So
Yeah,
it's basically still a barrier that we need to cross eventually as
yeah.
HPC support teams, but also as HPC engineers and so on. It's still a barrier that we somehow need to cross eventually to actually help the industry itself to use these resources. Okay, I think
Uh,
most of
the
this,
the
yeah,
industry is using these resources. I can tell you that they are using these resources. They they don't want us to specifically. They don't want to share with us specifically their trade secret. And in those cases, the best way to do that is a surrogate, something that is similar. It's not exactly the same thing, but it gives them enough knowledge that they can extrapolate for the rest.
it's basically a toy code that actually mimics
Yes,
their actual code. Yeah, that makes
yes.
sense, and that's one way to cross this barrier. But I do think that maybe like a closer interaction and a way to actually, not only through the surrogates, because sometimes even those surrogates code and to mimic the actual code can have good results, but can also have not so good results. But maybe we can actually, it's research, but also support and optimizations and so on in profiling. And I do think that these type of support teams, and probably everyone that is here in the chat already knows that, but these support teams actually help to improve the code itself. So it is important that people know that and understand how can actually help. I don't have a lot more questions. I actually would like to even see more of this in the next hackathon. So maybe we can talk a bit more on the following, not webinar, but actually in the following event that will happen in the hackathon. And we actually see the support team on the fly helping the users interact with these resources, optimizing, profiling, and so on. But I'm not sure if you want to add anything else, João.
No, I would advise you for those that have codes that they want to optimize to enroll for the hackathon. I don't know if that they are still open or not, but it's next week.
Yeah,
So maybe they are closed.
Yeah,
but anyway,
unfortunately it's are closed, but I do think that most of us already know something about that. And if not, there will be another opportunities on another hackathons actually already being built on. So maybe we can actually work together at some time.
yeah.
Okay, thank you so
So
much.
anyway,
Yeah, go ahead.
no, if you have any questions, if you need any support, please just contact us.
Yeah, absolutely. And there's a portal for that. Please reach out. And I want to thank you everyone so much for being here. And actually, please, you have a survey in the chat for you to give some feedback on this webinar and other webinars and so on. Even if you want to do actually another webinar on another topic that actually merges all of these on the EPICURE teams and the support teams, but also on other topics, because we already have actually a web series on a webinar series on profiling already scheduled, but we also have another webinar on the end of May done by Jeff Hammond from NVIDIA. So it's on multi-GPU programming, NCCL, and VSHMM. So eventually you can attend it. We'll open this registration as soon as the next week during the hackathon and so on. So please go ahead and check all the EPICURE events. And then we actually have a webinar series on profiling that we have 3 main talks done by Hilya Zukov and also other members on the pop metrics and so on. Then we have Laura Bellantini doing another one, and eventually Matteo Mordaca. So there are a lot of things on profiling that we need to use and to improve our code before actually doing code optimization. We need to profile, try to understand what is the behavior. So once again, thank you so much for attending, and please stay tuned for our communications channels and so on. And thank you once again. Thank you, João, and we'll see you next week on the hackathon. Thank you all.
See you all.